Hello viewers, Kinematics question 5. A person drives 127 kilometres from Hamilton to Auckland in 2 hours, stays in Auckland for 2 hours and drives back in Hamilton. The first task is to draw a distance versus time diagram of the situation. So the milestone times are going to be 2 hours when the person arrives in Auckland, 4 hours because they spend 2 hours in Auckland, so that's going to be when they leave Auckland, and then 6 hours, which will be when they return. So we need to draw a distance versus time diagram. So after 2 hours they will have travelled 127 kilometres, so 127 kilometres in 2 hours, and we'll draw a nice straight line connecting those 2 points. Between the 2 hour and 4 hour mark they don't move, so there is going to be no change in distance, which means a horizontal line. And then between the 4 hour mark and the 6 hour mark they travel another 127 kilometres, so they will have travelled by that time a distance of 254 kilometres in total. So that's what the distance versus time diagram of the situation is. Now we need to draw a displacement versus time diagram of the situation. And we need to define which direction we're taking to be positive. For convenience, let's take the northbound direction, so the direction of the journey from Hamilton to Auckland to be the positive direction. So north is going to be positive. Okay, so the displacement here is going to measure how far away they are from their starting point. So how far away they are from Hamilton. So at the 2 hour mark they are going to be 127 kilometres away from Hamilton because they were in Auckland at that time. And they stay in Auckland for the next 2 hours, so they're not going anywhere, so that's going to be a horizontal line. The displacement is not changing between 2 hours and 4 hours. Now, after the 4 hour mark, they begin the return journey. So that is going to be a negative displacement. They are travelling in the negative direction. They are returning back to the starting point. So the displacement at the 6 hour mark will be 0 because they're going to end up back where we started. So that will be what your displacement versus time diagram looks like. And also notice that the axes are labelled, and this should be labelled as well. So that's time in hours. All of these times are actually in hours for this question. Okay, so question C is to draw the speed versus time diagram, and at the moment we are assuming that when they are travelling, they're travelling at constant speed. So that's 127 kilometres in 2 hours, which is 127 divided by 2 is 63.5 kilometres per hour. Okay, so for the first 2 hours they are travelling at 63.5 kilometres per hour throughout their first 2 hours. And then they have a speed of 0 because they're not moving between the 2 hour and the 4 hour mark. And then between the 4 hour mark and the 6 hour mark when they're returning, they are travelling again at 63.5 kilometres per hour. So that is what the speed versus time diagram looks like. Now, what about the velocity versus time diagram? So the trip from Hamilton to Auckland, the trip there is going to be the same. They're travelling 63.5 kilometres per hour in the positive direction, in the direction from Hamilton to Auckland. So that will be a velocity of positive 63.5 during that time. And again, since they're staying in Auckland between the 2 and 4 hour mark, that's going to be a velocity of 0 during that period. But what about the return journey? They're travelling southbound, they're travelling from Auckland back to Hamilton, so they are travelling in the negative direction. So the velocity at that point during those 2 hours is going to be negative 63.5. So it's a negative velocity for the return journey. And part E is to draw an acceleration versus time diagram. So we have no information over how long these changes in velocity take. So at the beginning, we have an increase in velocity from 0 to 63.5, which happens pretty much instantaneously. So we're just going to draw a spike. And the velocity is increasing, therefore it's going to be an up spike. It's increasing from 0 to 63.5. At the 2 hour mark, the velocity is changing from 63.5 to 0. So it's a decrease in velocity. We're going to represent that by a down spike. What's happening at the 4 hour mark? Well, it's going to be a change in velocity from 0 to negative 63.5. So that's again a decrease in velocity, which makes that a down spike. And then at the 6 hour mark, the velocity is changing from negative 63.5 up to 0. So that's an increase, and we're going to represent that with an up spike. All we can really draw there are spikes because we don't have any information about the time that the change in velocity takes, which is going to be very small in the scale of the diagram, which goes from 0 to 6 hours anyway. It's essentially an instantaneous change in velocity. Now, what assumptions did we make? What would the diagram look like if these assumptions are relaxed? In other words, you don't make the assumptions. So the main assumption that was made is that there are no delays due to traffic, so that when the person is travelling, when the person is on the road, they're travelling at constant speed. But that's not necessarily going to be the case. There are going to be areas where they're on the motorway and they're travelling faster, and there are going to be areas where they're passing through a town and they're limited by the 50 kilometre per hour speed limit. There are also going to be issues due to traffic. So these, while we've drawn them straight lines, they're not necessarily going to be straight lines. They could end up being something a bit more like that. So it's not a straight line anymore. And the same is true for the displacement versus time graph. This is not necessarily going to be a straight line anymore, because you're going to have lots of tiny changes in speed. And with the speed versus time graphs, there are going to be times when they're going at 100 kilometres per hour, and there are going to be times when it's going much slower. So it could look something more like that. And again, the same is true for the return journey. So it's not going to be a straight line anymore. It's not going to be constant at 63.5. The speed is actually going to be a bit more all over the place. In fact, there might be times when it's completely stopped. And the same is true for the velocity versus time diagram. This is not going to be a horizontal line anymore. This is going to be variable. So it could have a maximum velocity of 100, assuming that this person likes to obey the speed limit. And we could have a minimum velocity of negative 100, which is when they're travelling at 100 kilometres per hour on the return journey. So this line, instead of being a straight line, could be something like that. In fact, let's also draw in here a point where they are stationary. Maybe they got hungry and decided to have a bite to eat on the way or something. And for the acceleration versus time diagram, well, what we've got so far is that the only changes in velocity are at 0, 2, 4 and 6 hours, but if the velocity is changing, then that means there will be other accelerations on the way as well. So there will be other spikes on the graph as well. So let's say we've got a graph that has lots of spikes that could be in either direction, but there's still going to be no spikes between 2 and 4 hours because they're not on the road during that time. But between 4 and 6, they are on the road and they are subject to possible delays and again changes in speed limits. So there will be changes in velocity and therefore there will be spikes in here as well. So this is what the acceleration versus time diagram in practice could look like once we acknowledge the fact that the velocity is not going to be constant throughout a 2-hour journey. Thanks for watching. Over and out.